Okay, our next topic is density. And density is an intrinsic or an intensive property, which means it's independent of the amount you have. So basically, um, the density of pure water, whether or not I have 1 drop or 1,000,000 gallons of pure water, the density will still be equal to 1.0 grams per milliliter at room temperature. Okay, so how do we calculate density? Here's the equation. Please know this, hold it very dear to your heart. We'll be using it quite a bit. And that's actually M is equal to mass divided by volume. Okay, now be aware volume changes with temperature, so your density will change with temperature. So with experiment 3, that's why we had to measure the temperature of the water before we could look up what the actual value was in our tables. Okay, what are the units? The units can be mass per milliliter, and oftentimes for liquids you use mass per milliliter, or we can use mass per cubic centimeter. Okay, we can use grams per liter. That's often used when we talk about gases. We could do kilograms per meters cubed. These are all in SI units, as long as it's mass divided by volume. Okay, when we use density, we can use density for several different functions. One, we can compare to tables of pure substances. Okay, to identify an unknown. And we do that sometimes. And if you'll hear the story about Eureka, that's how it was coined. Was that we were trying to look up the density, because we don't have to damage our sample to measure density. Okay, and 2, we can actually use as a conversion factor. Okay, and it relates mass and volume, 2 different types of properties, because they're both involved in calculating density. We can use density as a conversion factor between these 2. So let's talk about measurement of volumes first, and then start doing some calculation. So when we measure volume, we can do it calculation-wise. So if we have a sphere or a perfect cube, we can use our formulas, right? So with a box, we can use our volume is equal to length times width times height. If it's a sphere, we know that the volume is equal to 4/3 pi r cubed. Okay, so we can use formulas, but more often what we have to do with an object that doesn't have a regular geometric shape is that we have to do what we call water displacement. So the way it runs is this. Suppose here you are, here's your bathtub. There you are, enjoying your bathtub. Okay, and here's your water level. Okay, now if you had a little rubber ducky and you don't know the volume of your rubber ducky, then if you submerge your rubber ducky completely underwater, then what happens to your water level? Well, it turns out your water level rises because of the volume of your rubber ducky. So, if you measure the difference in the volume of the water, that difference will be equal to the volume of the duck. Okay? So you can actually get, for objects that aren't nice geometric objects but have very unusual shapes, you can get the volume through what we call water displacement. Okay? So, let's go ahead now and do some examples. Okay? So suppose we did this example. A graduated cylinder contains, let's say, 30.2 milliliters of water. Okay? Upon addition of a metal object the volume of water increases, okay, to 42.6 milliliters. Okay? And the mass of the object is, let me see what I can do. Let's say 107.3 grams. Determine, okay, the density. Of the object. Alright, so when we do this, the first thing is, let's just gather all our information. Obviously I'm going to erase the board because I don't have enough space. So I'm going to gather all my information and put it on the side. Okay, so what information do we need? We need the formula. Density is equal to mass divided by its volume. Now we know the mass. The mass, M, is equal to 107.3 grams. Question is, what is the volume? So what we did here, when you read what we've done experimentally, we're doing volume displacement. Okay? So the volume, I'll write it down here, is going to be equal to our final volume minus our initial volume. And since they're both to the tenths, we know we're going to be going to the tenths. So this is going to be a 0.4 to 12.4, not grams, sorry, milliliters. What was I thinking? Okay, so if I add this together, I should get my final volume. So now we know our volume. 12.4 milliliters. Okay, so now I'm going to erase it, and we're going to do step 2, which is putting all our values in the formula. So in step 2, since we have all our values, we put it into our formula. Okay, density is equal to the mass over the volume of that object. So we know that object's mass is 173 grams. The volume is measured to be 12.4 milliliters. Top is 4 significant figures, the bottom is 3. So our final answer should have 3 significant figures. Okay, and let me get my calculator. 107.3 divided by 12.4, and we get 8.653 grams per milliliter. Remember, whatever we do to our numbers, we do to our units, and it's grams divided by milliliters. Nothing cancels out, so that means my units. 3 significant figures, so I look past there. This is below 5, so I'm not going to change anything. 8.65 grams per milliliter. Okay, and that would be our answer. Alright, so that's how you would calculate density. Just get your values, put it in your formula. So let's try a different example. Suppose I said, determine the mass of an object okay, just get this evened out here. Alright, that has a volume of, say, 5.48 cubic millimeters, alright, and a density of 19.3 grams per cubic centimeter. Okay, so I have different units here. So we're going to have to do a multi-step problem. 1, we're going to have to convert cubic millimeters to cubic centimeters. So convert cubic millimeters to cubic centimeters. Okay, and then 2, since we're looking for the mass, we know that our equation density is equal to mass over volume. So if I multiply both sides by volume, mass is going to be equal to density times volume. Okay, so once I have the right units, I can cancel that out and get my mass in grams. Okay, so let's go ahead and do the conversion first. Okay, so it's going to be, if we look, it's 10 millimeters is equal to 1 centimeter. Alright, so how do we get that? Well, if you go through, if I do this conversion, let's go through our base. So 1 centimeter, so 1 centimeter down here, 1 times 10 to the minus 2 meters, and I want to convert it to 1 times 10 to the minus 3 meters is 1 millimeter. Okay, cancel out our units. So we know that 1 centimeter is equal to 10 millimeters. Okay, so that's how I got this conversion. Okay, however, bear in mind, we're not looking for millimeters, we're looking for cubic millimeters. So there are a few ways you can do this, okay? But in this case, if I say 1 centimeter, I'm going to cube it. The whole thing has to be cubed, not just the unit, but the whole thing. But 1 times 1 times 1 is equal to 1, okay? So then I take my 10 millimeters, and whatever I do to the left side, I have to do to the right. So if I cubed here, I need to cube there. So 1 cubic centimeters is equal to 10 times 10 times 10. So 1,000. I have to cube my millimeters. So I have to do the same thing to my unit. So 1 cubic centimeter is equal to 1,000 cubic millimeters. Okay, so now we have our conversion unit. We can do step 1. Okay, so the main part is actually getting this conversion. Okay, so if I have 5.48 cubic millimeters, now we know 1,000 cubic millimeters is equal to 1 cubic centimeter. Okay, then we know it's going to be equal to 5.48 times 10 to the minus 3 cubic centimeters. Okay, so now we finished step 1. We have our volume and it's in cubic centimeters. So now let's work on step 2. So I'm going to erase this part on how we got our conversion unit, and now we're going to use this formula. So when we use this formula for step 2, okay, mass is equal to density times volume, and our density was given at 19.3 grams per cubic centimeter. Notice how the slash means that whatever's on the right hand side of that slash is on the bottom. I just wanted to make sure, since you're getting all sorts of different ways we're writing these units and dividing, times 5.48 times 10 to the minus 3, so that would be EE minus 3, negative 3 cubic centimeters. Okay, and I'm just going to erase this part now that we've rewritten our volume, so we don't confuse it with step 2. Okay, and so now let's take a look at what our final answer is. This is in 3 significant figures, and this is in 3 significant figures. So our answer will be in 3 significant figures. Okay, we get something like 0.10576 grams. My units here, cubic centimeters, cancel out. We know we want 3 significant figures. 7 is greater than 5, so we know we have to round up. 0.106 grams, and that will be our mass. Okay, so that's how you would use density to convert from a volume to a mass. Now, let's go the other way. So, determine the volume of an object that has a mass of 525 grams and a density of 1.3 0.37 grams per milliliter. Okay, that's not a question. Okay, so we notice that the units, grams and grams, are the same, so we don't even have to do conversion in this case. So what are we going to do? So we just need to know our equation. If we know density is equal to mass divided by volume, then if I multiply both sides by V and divide both sides by D, okay, then that is going to be the equation that we're going to use. So let's go ahead and put in all our values. 525 grams, and that's divided by 1.37 grams per milliliter. Okay, so my units are milliliters. The grams divide out, and then this is basically looking at my units. We'll do the numerical calculation in just a moment. This is a 1 divided by 1 over milliliter. And we know this is equal to milliliters. So if you have difficulty remember, what is 1 divided by 1/2? You take this fraction and you invert it, and that's going to be equal to 2. That's all we did, was we inverted it, and that's going to be equal to milliliters. So we know that the units are good. Okay, so it's important to use your units as a guide. Okay, so when I divide 525 by the 1.37, I get 383.21, okay, milliliters. And we said 3 significant figures, 3 significant figures. So we're going to stop here. This is less than 5, so we're not going to round up. We'll leave it alone. So we get 383 milliliters is our final volume. Okay? So what happens if we did something like this? Our last example. Use this color. Okay. Determine the volume of an object that weighs 15.21 pounds and has a density of, let's say, 3.85 grams per cubic centimeter. All right. Now, what do we need to do? Look at the units here are different. This is in pounds, and this is in grams. English to metric. So we're going to have to, 1, convert pounds to grams. Okay? And then we can use our formula. Density is equal to mass over volume, and convert that equation. We're looking for volume, so volume is equal to mass divided by density. Okay, what we need to do here, make sure our units are in agreement. Okay, so when we look it up, we know that 1 pound is about 454 grams. Okay, so this is, you're going to look for your conversions in your textbook. Another one that we always use is 2.205 pounds is equal to 1 kilogram. So you can do those conversions too, but we'll go with this one. Okay, so for step 1, before we even use our formula, 15.21 pounds. Why do I keep using B for pounds? It's LB. Okay, our conversion, you know that 1 pound is equal to 454 grams. Okay, and even though you can fine-tune this and get more significant figures, I'm just going to use this, okay, to determine my significant figures. All right, because clearly that one's measured. So 454. So we get something like 6,905.3, 1, 2, 3, 4 grams. Okay, now let's do step 2. Oh, excuse me. So step 2, we're just going to go ahead and plug in our values, all right, into this formula. So for step 2, volume is equal to 6,905.3 grams, okay, divided by, I did this so I remember, this should be 4 significant figures, 3.85 grams per cubic centimeter. Okay, so the grams divide out, and 1 over cubic centimeter is equal to cubic centimeter, and that indeed is good because that's a unit for volume. And now we can just divide the two numbers. This is 4 significant figures, this is 3. So we're going to go ahead and give the value and answer in 3 significant figures. 3.85, so I get 1,793.59. We're going to 3 significant figures, so 1.79 times 10 to the third cubic centimeters. Okay, so let's just quickly go through how I got that scientific notation for my answer. Okay, so what I can do is I'm going to move this 1.793 times 10 to the third. Okay, and we know it should be 3 significant figures. Now you get 1.79 times 10 to the third cubic centimeters. So when you do this, just take it one step at a time in terms of scientific notation and rounding. Okay, and that's density.